today I'm going to do a video about the Model Context Protocol. So this is a very powerful tool to overcome many of the challenges with modern AI, especially for state and local government, and the struggle to integrate all of that siloed data for AI. A little bit about me here. I started out life as a computer scientist long ago, working in AI and machine learning. I eventually joined the state of Louisiana, where I worked for about 20 years and moved up through the ranks and was lucky enough to become the state CIO. I want to start out today with a bit of a scenario. And being from Louisiana, hurricanes are always an imminent threat. And I've been through a lot of those and done a lot of emergency activations. So imagine a Category 3 hurricane spinning up in the Gulf that could make landfall in Louisiana in roughly 32 hours. Mandatory evacuations are already underway. There's a storm surge you have to look at, 3 coastal parishes likely to be hit, 41,000 residents are on the move. Some of them are going to need shelter of last resort provided by the state. You need an emergency evacuation plan, and you need it now. The critical information and pieces for a plan of that size and complexity live in a lot of different systems. You have different databases, different agencies, different logins, and right now there'd be some poor emergency operation coordinator trying to make phone calls, opening a million browser tabs, trying to stitch all of that together manually. Every hour, though, that storm is getting closer, and it could cost lives. So what if you could just ask an AI agent to pull all of that together for you? Where to go, and it could come back with a full shelter activation plan in minutes. And it could even ask you, should I start activating parts of this? It's not science fiction. This isn't something that would be 3 years and tens of millions of dollars to implement. I want to go over this today and hopefully convince you that by the end of this video, this is something you could start now and hopefully have up with infrastructure you already have in place in a matter of months. So before I do that, though, I want to talk a little bit about a baseline of why MCP is needed and what the problems are with modern AI that it's trying to solve. The original sin of a lot of these large language models that we have out here now is that they're trained on gigantic amounts of data, these training sets, but those are point-in-time data. So once that model is trained, it's already out of date. Anything after the fact from that training data, it doesn't know about. This includes, any sports score, recent news, a stock ticker price. But in state local government, any eligibility rule, any budget balances, staff rosters, weather forecasts, basically every operational fact that actually matters is out of date for these LLMs. And this is ignoring the fact that these are trained on public data, and it wouldn't even have any of the data that you house internally to start with. A whole lot of work has gone into making up for these shortcomings over the past 5 years. The first part of this was to drastically increase the size of the context window. When we talk about a context window, this is the amount of stuff, the data, the tokens that you give an LLM as input. LLMs don't have persistent memory. They don't have context built in by default. So everything the model considers at one time goes into that context window. This includes your query, if you have a conversation history, any attached documents you've given it, and back-end system instructions. Providers might put things in there like, don't tell people how to make a pipe bomb or don't curse at them. All of that's in the context window every time it goes to that model. The size of these context windows has absolutely exploded over the last 5 years. So 5 years ago, it was about 2,000 tokens, and today we're up to about 10 million. So it's a 5,000x increase. To put some of that in perspective, 10 million tokens is about 7.5 million words. That's like taking the Lord of the Rings trilogy and copying all the text in all 3 of those books and pasting it 15 times over into the little input window for your LLM. But this gets useful because if you wanted to know if a new piece of legislation is going to impact you, you could take that new legislation, you could paste in the text or attach the document into the context window along with your query, and suddenly the LLM now has a frame of reference and understands something that it wasn't trained on and can give you a meaningful answer. So this works pretty well, but there's some downsides to using context windows directly. It's a manual process. When you have these incredible logic engines, you don't want to have to go out and find all of the relevant data that's up to date yourself every time you want to ask it something meaningful. You can also run into a bit of a focus and accuracy trap where if you load up too much information that might not be exactly relevant into that context window, the LLM can kind of forget or lose focus on what it's trying to do. The last piece of this, and maybe one of the most important, is there's a tendency to put huge amounts of data in that context window to make sure that the LLM has everything it could possibly need. Imagine that you're looking for some sort of meaning about a passage in a book and you don't remember where it is, so you just copy and put the book in there. You're going to burn a ton of tokens when that LLM has to parse that entire novel and go through all of that to find just the small piece of data that it needs. This gets very expensive very quickly and burns a ton of computation to do that task. To help offset this, the solution they came up with is fairly simple but pretty novel. Basically, we're still leveraging the large context window, but we're going to automate the way things get added to it. Many of you are probably familiar with this. It's a process called retrieval augmented generation, or RAG for short. A lot of people have a misconception that RAG is something that's built into the LLM. In truth, what happens is when you ask your query, there's a RAG that sits between you and the LLM, and it intercepts that query, and it goes to what's likely a vector database, might be a web search, but it goes and looks up and it tries to determine on its own what might be relevant data, and it injects that back into the context window for you, and then sends it to the LLM to help give a more meaningful response. So this does a lot of cool things. One, no more manual search. You just put in the query and it finds that data for you. Number two, the data is now managed in a single location. You likely have a vector database attached to that RAG engine. And if you have a lot of different sources, you can collapse it and manage it all there. The security around it is in one place. The other thing is that only the data that it thinks is relevant is returned. So you don't have the whole novel going in. And this can drastically cut down on the amount of tokens and computational power that you're going to burn. So now the user doesn't have to manually load the context. Problem solved. Almost. You still have an issue because you have to manually or batch refresh the vectorization of all the data that's required. And it's still not real time. So this requires all the data that you want to be available as potential context to be duplicated and vectorized into that vector database. So now you have a massive duplication tax. You're going to have all this infrastructure and all the people to manage that. And if you have 50 petabytes of data that you need to make available, you're going to have to run a 50 petabyte vectorized database. But also, RAG will struggle to get meaningful context for very complex queries. And as AI gets smarter and smarter, the queries we give it tend to be more and more complex. This is a really important point because the super powerful reasoning engine, the LLM that we have and we're using, is in no way utilized to determine or request what data it needs. All of that is decided beforehand, and the LLM has to make do with whatever it's given. So for that problem, we lead into what's the new hotness now, agentic AI. This is where you have kind of a planner agent, and multiple agents are broken out under that and given focused tasks so they can individually pull that content to help ensure that they get more relevant data. The responses go back through the planner, and the agent returns that to the user. And this kind of solves the issues with RAG models being overwhelmed by complexity that provides better utility for the complicated multi-step queries that you're likely to start getting. But while this is one step forward, it's kind of two steps backwards. The agents are still typically reading from those RAG indexed copies and not the source system, so it's still not real-time data. The reasoning engine isn't making the determination on what it needs. And every agent you have now may need different data sets. And this may mean that you have to set up different RAG engines or that you want to localize data. For example, an AI agent that specializes in finance may need access to financial data only. For SLG, this means that of the hundreds and hundreds of systems you likely have sitting out there, you're going to have different authentication, query logic, error handling, and ongoing maintenance for all of these different agents. It quickly becomes completely untenable. So the takeaway from all that is really that the biggest barrier to implementing AI a lot of times has nothing to do with the AI itself. It's the plumbing around it. And unfortunately, to solve that plumbing problem, what we've done is build even more plumbing around it. What we need here is a universal adapter, and that's where Model Context Protocol comes in. So the idea behind MCP is pretty easy. The way it's laid out is you have your AI host. For this example, I'll be using Claude, but any agent that supports MCP could do it. Inside that agent, it'll have a connector that supports the MCP protocol, and that's your client. Then you have an MCP server, which is usually just a lightweight server that exposes an endpoint with that protocol to connect to. Now, if you're listening to this, you may be thinking, great, you just reinvented APIs. And you're not totally wrong with that. While this is a lot like APIs, there's a major difference, and the magic word there is discovery. So when an MCP client connects to the server, the MCP server itself describes what it does. And then that LLM can take that and it determines what parameters it needs to send and what it's going to get back. And it makes the determination when to call and how to call those MCP services. This is really different than an API because normally you would have a programmer on one side and you would have an API specification sitting out there that programmer would have to read, and you would have to custom write for that API. Here's the headers I need to send, the parameters, here's how I pass my authentication token, here's what I'm going to get back, here's how I handle errors that I may get, etc. None of that happens with MCP. So a really good way to think of it is along the lines of USB. If you're as old as me, you may remember when devices all had their own ports. You plugged your printer into an LPT1 port, your mouse went into a PS2 port, and then USB came out. And now you can just plug anything into a USB port. That device will describe itself, and then it'll load the correct drivers, and it'll just work. That's the way MCP is designed. So this sounds a little too good to be true, but I'll show it to you here in a minute. But there's more to it than that. Because of the way it works, it just layers on top of all your existing systems. So the APIs you have, the systems you have in place, you do not have to modernize. Putting the MCP server, the client, and the agent LLM on top of those does not affect anything at the bottom of that stack. And in most cases, you can just tie in directly to those existing APIs or your API gateway without having to make any changes. So the last thing here is that this adoption is really already happening and has happened to a good extent. It was developed by Anthropic, but it's an open standard, so anybody can support it. Anthropic doesn't open it. It's already used by Google, Microsoft, GitHub, Slack, Stripe, Shopify, Cloudflare, on and on and on. Even last month, I believe, Microsoft announced that they are officially going to have an MCP server for SQL Server to support connectivity directly. Thousands and thousands of community-built projects. It's a massive ecosystem. The point here is really this is not an experimental thing or art of the possible. This is production infrastructure at the largest tech companies in the world. So why does this matter so much for state and local government? You know, when I was in the CIO seat, I would have killed for this once I realized what it's actually doing. Because in SLG, we have the APIs. The other thing we always have too is the security and the authentication piece. With MCP, your SAML, OAuth, PKI, your role-based access, it all passes through. So you don't have to put another security layer with MCP. Whoever has access directly to those APIs or that data, that will pass through and they will authenticate the same way just through the MCP client. The data is already there. You have compliance systems as well. You don't have to duplicate that over into a centralized system or commingle it. And a lot of people don't understand that for state and local government, those siloed data systems are usually there by law, right? Agencies have the legal data stewards of that restricted data, so you can't just dump it all into something like a vector database, at least not if you want to stay out of jail. So the sky is the limit. These are some use cases we've come up with, but there's a million of these you could get into, things like fraud, waste, abuse, or public safety use cases. These are just to get your mind thinking about all the places and the systems you could potentially plug this into to do reasoning for you. But now, the exciting point. I really want to show this in action with the live demo. So I'm going to jump back into that scenario we had at the beginning. Category 3 hurricane is forecasted to make landfall in 32 hours in Louisiana. We had the mandatory evacuations that were underway, roughly 41,000 residents under orders to get out. And some of those are going to need shelter of last resort provided by the state. We're going to have to look at the facilities, do all the logistics to get those shelters up and running, supply them, staff them. We're going to have to look at the budget, FEMA reimbursement posture. We're going to have to send out the alerts. All of this within this 72-hour operating window that has to be there for our lives could be at risk. So what I've done here for this demo is I've gone ahead and I've set up 6 MCP servers. I wanted to make this as realistic as possible and not something that was really slimmed down. So I have the weather service, I have a facilities management service, I have a personnel system, an inventory management system, a budget and finance system, and a citizens alert system. These do roughly mirror what kind of we actually have in Louisiana. For example, we can send out alerts and we have APIs to do things like SMS and email where citizens subscribe to those, or reverse 911 just for these type of emergencies. I'm going to go ahead and jump into my client here. First thing I want to show you is exactly how I have these connected. So you can see here that I do have all of these up and running. All 6 of these are up. It shows that they're connected into the client and it's aware of them. So what I'll do, so I'm going to go ahead and kick this off. We'll talk a little more about it while it does some thinking. but I'm purposely going to give it a very bad prompt. I'm going to give it one sentence. Create a shelter activation and emergency plan for the hurricane threatening Louisiana. I'm not going to tell it anything about the weather of the hurricane. I'm not going to tell it who I am, what I'm doing, what else is going on, what's needed. And the purpose of this is because now it can go get its own context. And while this is a bad idea generally to do, I want to really press the model and show you how much more powerful it becomes when it can go get its own context and figure out what it needs. So I'm going to kick this off. Now we can talk a little bit about how this would normally be handled within an emergency operations center. When these hit, and I've been through a lot of these, the first thing is there's a team that has to, in real time, constantly check the weather. How severe is the storm going to be? What's the timeline, the wind speed, the storm surge? Where is this going to hit? What's the path it's going to take? Everything gets framed around that, right? You can't start building out where you're going to put shelters and where the staff needs to be and what supplies you need until you understand those critical pieces. There's a team specifically that'll go and look at things like the facility. You have to filter by the capacity, ADA compliance. Do you have backup generators? Then you have teams that have to find all the staff. Are they certified? Do they speak the language based on the demographics of people that may be coming in? You have to have teams that are going to look at supplies. What do we have? Where are they at? What warehouses are those? What vehicles do we have to get those supplies? How long are they going to take to get out there? When do we need those trucks on the road? You have financial groups that are looking at the emergency fund balances. Are we going to be reimbursed by FEMA? How much is this going to cost? Do we need to encumber these funds for the state? You have to put together your plan on notifications. And then you have to take all of this and roll it up to some emergency coordinator or group that's going to put this into a single actionable plan and then roll it up usually to the governor for authorization. Okay, so I'm going to jump back here and we'll see. We've given a little time to think. Let's see what it's done. So the first thing here, you can see that it started looking and it's determined that it needs to figure out what's going on with this storm. And luckily here, it lets me break these out and shows in the background atomically what it's doing at each one of these levels. So you can see it did find and realize that there's a weather service out here exactly for these kind of emergency alerts. And it's reached out itself on these MCP services and started getting information about the hurricane. So it finished that one piece and says, I've got it. Category 3, 32 hours to landfall. It knows where it's hitting. It knows a mandatory evacuation is active. And it knows now we need to start looking at shelters that are inland in parishes well outside the surge belt. Doesn't do us any good if we have a bunch of places to house people that are underwater. So here again, it starts going through the MCP services. It knows what parishes to look in. And by the way, for anyone outside of Louisiana, a parish is a county everywhere else in the United States. But it knows what parishes to look in around the areas that are going to be impacted but are not going to be underwater themselves. They're not going to be part of the storm surge. So it's done that logic for us. So it finds one and says that that's not going to be enough, and it started to expand where it's looking. So now it's finding additional facilities. You can see it's adding the capacity based on how many people it thinks are likely to need beds. It's determined that up to 1,200 people may need to be at these facilities. And so now it's started looking at a shelter management and the personnel that need to be deployable to those parishes and those areas. So here you can see again, it's going into the system and it's starting to pull people, what they do, their backgrounds, what languages they speak, their titles, and where they live to get to these areas. So now we have a level 11 certified staff, and now it's starting to look at medical capacity as well. You can see here, it's searching on its own by certifications, looking for registered nurses, it's looking for EMTs, it's flagged these, now it's looking for French Cajun capacity, but it knows too the medical coverage is thin. It'll flag anywhere, too, that there might be issues that you have to resolve later or that it needs to get additional folks for. So this keeps going. Now it thinks it's got enough staffing. Right away, it shifts to start looking at warehouses, supply, and vehicles. It goes out on its own, starts looking through the system, the facilities, seeing what facilities are available in these areas and what sort of inventory they have. On its own, as it gets these, you'll see that it starts looking at its own categories, looking for water, looking for food, checking for medical supplies, power, figuring out what generators are there. Once it gets all of this stuff and it knows that it has enough, now it's started building the actual logistics behind this. It's looking at what vehicles need to go where, at what time, what they need to pick up from what warehouses, and where they need to deliver them. It's also calculating how long it'll take to get there so to make sure they aren't impacted by the storm itself. Finally, it gets down to the budget, starts finding funds in the system, goes through. We know what's going to happen, what the timeline looks like, and it's starting to add up and find the cost that it thinks it's going to be. Estimated comes to 286,000, says there's 396 available on an emergency fund, which is enough to cover it. But it also says before it finalizes anything, it needs to put some alerts together for the citizens. So you can see again, it's determined on its own and found this emergency alert system. It's found all the types of alerts it can send, the restrictions behind those like links and SMS texts, and it's gone ahead and built out drafts for all of those different types of messaging. All right, finally we get to the end and it says it's done. It takes all that and stitches it back together for us in a single shelter activation and emergency plan. So now we've got the sit rep. We've got the shelter network laid out for tier 1, 2, and 3. You can see the tier 1 shelters here. These are things with permanent diesel generators. They have full kitchens. They have showers. They're ADA compliant. We have tier 2, smaller generators. They're pre-staged. And then tier 3 that is really saying only to use as an emergency overflow shelter, no permanent kitchen, and it would require a portable genset to come in there and operate. It's also broken out for us all of the staffing, who's running the leads, who's going to be coordinators, who's going to be the registered nurses, EMTs at these areas, all the way through. It's identified some staffing gaps that we'll need to use a volunteer coordinator to fill. Then it goes into all the supplies and logistics. So it has figured out everything that needs to happen, what those timelines need to look like, and where the supplies need to go. Here's an interesting one too. On the public alert, it's drafted these messages for us, but at the end here, it says, on your go, I'll call send alert against the appropriate zone IDs. So it's built these drafts, but it's also realized I can do more than just pull data and stage this for you. I can actually send these alerts out. That availability is in the system and I can make that call. But it realizes that this is a state-changing action and waits for my authorization to do it. In a similar way, it's built out the entire budget for us, broken it down, and even aligned it and tagged it for FEMA reimbursement to help speed the process of getting federal dollars back. It's identified critical gaps and risks, full decision timeline, and then here at the bottom, it points out very explicitly 2 actions need your go before I execute. 1 is sending the public alert, and 2 is actually encumbering the funds in the financial system. So it's realized not only is that money there, but it can go in and do the encumbrance for you. So I'm going to go ahead and tell it to do these things and authorize it. So now it's carefully getting all of the channel IDs, making sure these are going to the exact right places, loading those channels, the alert zones, confirming everywhere it needs to go, what languages it needs to be sent in, 8 zones, 5 channels in English, Spanish, French, and Vietnamese to match all the demographics of those zones. And here we go. It's called the alert and it's completed and we've gotten the ID back. We can go into the logs and see this on the other side if we want. It's also given the estimated time of delivery based on the message type. And now it's working on encumbering the funds for us. And there it is. And now we have the funds encumbered and we're ready to go. And we can go ahead and make this in a document to present up the chain and get approval to move with the rest of the plan. So this is 6 different systems, and here in a couple of minutes would have been likely hundreds of man hours, and in real life probably taken an EOC 4 to 5 hours to get done. We've done in a couple minutes just by exposing the system through MCP to a single AI agent. So this is a lot. It really demonstrates how powerful these LLMs can get when you expose additional systems and leverage and resources to them, and they get to make the decision of when to use those and how to use that data. But there's 3 primary takeaways here I want to focus on. So number 1, MCP gives you the ability to use what you already have. It's not a greenfield build out. It's not modernizing new systems. It's using the systems and the data that you already have. Second is that it gives you access to all that siloed data and changes the way that you can use AI immediately. It's not a long-term project. It's not 3 to 5 years down the road. It's available right now. And you can start using MCP right now. You can build these servers. It doesn't take a ton to do. All 6 of these servers and the data for that demo took me less than a day to write. And, I'm at this point probably a hobbyist coder at best because I've been out of the game for so long. So if there's one thing that 20 years of state work has taught me, it's pragmatism. The reason I'm so excited by this is I know exactly what this would have meant to me in the state of Louisiana had this been available 2 or 5 years ago, and I had been able to put something like this in place. You don't need a large upfront investment to start using MCP and modernize with AI. I encourage everyone out there, if you're not using it already, just start building. Give it a try, see what you can do, and then just keep going. That's all it takes. On behalf of myself and Dell Technologies, I sincerely hope that you found this useful, and thank you very much for watching.